Good morning to all of you fabulous fives out there. So glad you could join us again this morning. Ready for maths? I hope you are. Just wanted to check in to see how your times table challenge is going, the one you set for yourself, where you check how fast you can do your times tables correctly. Right is better than fast. So first make sure you're getting it right before you practice your speed. But once you've got it right, check the time it takes you to do one of your times tables, and then practice and see if you can do a little bit faster. If you've done a really good time and you'd like to challenge me, or you'd just like to tell me about it, drop me an email at grade5@worksheetcloud.com. Perhaps you've done a really brilliant time and you want to see if I can beat it. Definitely have some students who can do it faster than me. I hope that there are some of you out there who will be able to do your times tables better and quicker than me. That would be fantastic. Just a reminder, there's the email if you want to email me, if you want to ask me a specific question, if you're having difficulty with anything, if your teachers are sending you some work and you're a little bit unsure, you'd like me to cover that topic in a future lesson, let me know as well. Or if you've done a fantastic time in your times table challenge and you'd like to test me, let me know via that email address as well. After the lesson, you can click on the link above to get the worksheet, just to check that you've managed to master the things that we do in this lesson. This lesson, we are adding and subtracting fractions again, but this time we're doing it with mixed fractions mixed numbers or mixed fractions, which we'll go into in a moment. And we are also going to look at quickly counting in fractions, and that should round out our fractions work for now. So our lesson goals pretty much in line with the title of the lesson, adding and subtracting mixed numbers or mixed fractions. Just a note that we won't do any with carrying or borrowing. That's something I'll show you, but I'm not going to work it out. I'll show you what I'm talking about with that at the end of when we're doing that section. And then also counting in fractions, both forwards and backwards. Okay, before we go on to this, let's quickly look at our homework from yesterday, because we are still going to be adding and subtracting fractions today, just slightly different looking fractions. So maybe let's go through our adding and subtracting of fractions. There's a lot that's similar between what we're going to do today and what we did with adding and subtracting fractions. Looking at A, first we need to check that our denominators are the same. They are. So we can go straight into doing our answer. 6 minus 1 is 5, and there we go. Correct answer. With the next one, the denominators are also the same. I did warn you that we would have plus and minus together, so you don't get into the habit of just subtracting. I hope you didn't subtract this one. It says 7 plus 1, which is 8, and taking it the extra step, we know that 8 divided by 8 is 1. And you needed to, because we practiced that in last lesson, we need to make sure that you get it to writing it as 1. It's not incorrect to write it as 8 over 8, but it's just a neater and nicer and prettier way if we write it as 1. The next one was a subtraction one, but our denominators are not the same, so we first need to make them the same before we do our adding or subtracting. In this case, subtracting, I noticed that 3 can be made into a 9 because 9 is in the 3 times table. 1 times 3 is 3, 3 times 3 is 9. Please make sure you keep the same order, and by that I mean that the first number comes first and the second number comes second. This one I'm just rewriting, I'm not changing it at all. Denominators are now the same. 3 minus 1 is 2. There's our answer. Looking at the next one, also we need to make the denominators the same before we can subtract. I noticed add, not subtract. There's me using the wrong word. It does say plus. If I times it by 2, I can get it to be 8 as well. So the first one stays unchanged, 5 over 8. The next one, 1 times 2 is 2. 4 times 2 is 8. My denominators are now the same. So I can add 5 plus 2 is 7. Tick. I hope you're ticking, and if you didn't, as long as you're learning from your mistake, that's absolutely fine. The next one, 4 and 3, they're not the same. I need to get them to be the same. You can't make one of them into the other because neither of them is in the other one's timetable. So you can either work it out in your head or you can jot down your times tables on the right just to check. Here we go. We're going to make them both into 12 because 12 is in both of their times tables. So I'm going to times this side by 4 and this side by 3. Oh, that's a little bit tiny. I hope you were listening closely. So 1 times 4 is 4. 3 times 4 is 12. First fraction rewritten as an equivalent fraction. The second one, 1 times 3 is 3. 4 times 3 is 12. I now have the same denominator, so I can subtract them. 4 minus 3 is 1. Done. Next one, 5 and 2. Can't make them into the other. I'm going to jot down my times tables. So 2, 4, 6, 8, 10, 12, 5, 10. There we go. 10's in both. I'm going to make them both into 10s. So to get a 5 to a 10, that's 2, 4, 6, 8, 10 times by 5. Same to the top, because what we do to the bottom, we do to the top. 1 times 5 is 5. 2 times 5 is 10. On the other side, to get a 5 to be a 10, 5, 10 times by 2. Do the same to the top. 1 times 2 is 2. 5 times 2 is 10. Our denominators are now the same. So we can add them. 5 plus 2 is 7. Tick. 2 more to go. Again, 4 and 3, not in the same times table, can't make one to the other, so I'm going to quickly jot down my times tables. This is, again, why it's so important to know your times tables, because it's easy. So I know my 4 and 3 times table, I know 12's in both, I don't need to jot down my times table, and if you guys know your times tables, you will also find it much easier to find the common denominator, the same fraction for both. So I'm going to times by 3, times by 3, times by 4, and times by 4. I get 6 over 12. I get 4 over 12. Denominators are now the same. I can subtract. Done. Last one, 3 and 5, 5 and 3. Let's do our times tables again. There we go. First number in both of them is 15. Just move my screen up a little bit. So I've got to make them both into 15. So 1 times 3 is 3. 3 times 5 is 15. Times by 5, times by 5. 2 times 5 is 10. 3 times 5 is 15. It's an addition. Sorry, yeah, that's right. So I get, it shouldn't be there, 13 over 15. There we go. Right, that was our homework. Jumping back to our fractions work. Yes, adding and subtracting mixed numbers. What is a mixed number? So a mixed number is also called by some a mixed fraction. And examples of mixed fractions are things like this, where we've got 2 and a half. So there's a whole number part and a fraction part as part of these same numbers. So 2 and a half is a mixed number or a mixed fraction. So let's just take a moment and understand what that means. So we're looking at halves. So let's draw it as squares. So when I'm looking at this, I've got 2 and a half. That's what 2 and a half means. 2 wholes and a half. Right, so in other words, I have 1, 2, 3, 4, 5 halves. 2.5 is the same as 5 halves. All right, that's actually something you only need to worry about for next year when you are converting between mixed numbers and improper fractions, but you don't need to worry about that for now. So incidentally, as a little bit of an aside, the kind of fractions you've been looking at the moment, like that one, that is a common fraction, or also known as a proper fraction. And proper fraction being that your numerator is smaller than your denominator. Okay, so we've got mixed numbers over here. And we've got common fractions over there. We do get a third kind of fraction, which again, we're not going to look at this year, but just so that you do know, something like this, where we've got 3 halves, and we call this an improper fraction. And to be an improper fraction, your numerator must be bigger than your denominator. Good. Let's have a look at one more mixed number. 4 2/3. So again, if we were to draw this, we have 1, 2, 3, 4 wholes and 2/3. So that's that fraction drawn out like that. In the work we're going to do, we actually don't need to worry about, let's just move that out the way. We don't need to worry about, well, we don't need to worry too much about the fact that this is made up by halves. What we're going to do is to have a look at ones like this. So I'm going to do a couple of examples, and then if you're feeling confident, you can go ahead. So the first one, (1 1/3 plus 2.5). First things first, the same rule applies. We can't add until our denominators are the same. So let's make them the same. I hope you can see that we can make 2 and 3 the same. We'll find a number that they both go into. If you can't, just jot down your times tables on the one side. 2, 4, 6. So 6 is the first one. So we want to make these both into 6. So if I times this by 2 and this by 3, and this by 3 and this, oh my goodness, careful, what you do to the bottom, you do to the top. So both by 2 and both by 3. Now, I'll show you in a moment why the whole number doesn't change, but the whole number stays the same. And 1 times 2 is 2, 2 times 3 is 6, plus the whole number stays the same. 1 times 3 is 3, 2 times 3 is 6. Right, so that's what it looks like. The reason the whole number stays the same, if this was my whole beforehand, broken up into 3 pieces, would look like this. 1, 2, 3. And this is my whole over here. If I broke it up into 6 pieces, 1, 2, 3, 4, 5, 6, it's still the same amount. So it doesn't actually matter for the whole number what you change the denominator to. So we actually leave the whole number unchanged, and we just change the fraction part. So these fractions are equivalent, and these fractions are equivalent. I haven't changed the order. Haven't changed the whole number, just changed the fraction part. Now that I have them being the same, I can add it as follows. 1 plus 2 is 3, so my whole number is 3. Same rule for adding the fraction part. The denominator doesn't change. Now I add the numerator. 2 plus 3 is 5. And that is how we do adding with mixed numbers. So let's have a quick look at a subtraction one. I think if you get into the flow of it, we'll do a few of these, but if you get into the flow of it, you try and go ahead of where we are, where I'm working. And if you want to challenge yourself, you can pause the video and try it all on your own, and then restart the video to watch to see if you got the right thing. Okay, so first things first, we need to make our denominators the same. They both need to be the same. I'm going to jot down my 5 and 4 times table. There we go. We got to get them to both be 20. So leaving the whole numbers unchanged. 6. I times this by 4. I get 16 over 20 minus whole number unchanged times 5 times 5, 5 over 20. Now that my denominators are the same, I'm first going to subtract my whole numbers. 6 minus 1 is 5. Denominator stays unchanged. 16 minus 5 is 11. And there is my answer. Right, now I think you're getting the hang of it. So the only difference between this and what we did yesterday is that we first add or subtract the whole numbers. All right, so that's really it. That's the only difference. Here's number 3. I'm going to also write down number 4, so if anyone wants to go ahead, they can. Right, looking at number 3, I need to make my denominators the same. I think we've done this combination of 3 and 4 enough times that you should realize that they both go into 12. So I'm going to times that by 3, times that by 4. And my whole number stays the same. 1 times 3 is 3, 4 times 3 is 12, plus 2 stays the same. 1 times 4 is 4, 3 times 4 is 12. Now that I have them the same, I can add the whole numbers. Then I'm going to keep my denominator the same. 3 plus 4 is 7. For the next one, I notice I don't have to change both of them. I can just change this one. So the first number stays entirely unchanged. The second number, the whole number, stays the same. 1 times 3 is 3, 3 times 3 is 9. Now that my denominators are the same, I can do my subtraction. So 3 minus 2 is 1. Denominator stays the same. 8 minus 3 is 5. And there we go. So I did have 2 more examples for us to do, but I think let's rather leave them. I think that by now you should be understanding that it's pretty much the same as what we have been doing. We just make sure that we minus the whole numbers separately in order to get that right. I did also mention that there was harder work coming next year. And I'm going to show you what I mean by that harder work, but I'm not actually going to do the problems. I'm just going to show you where you might, in case you come across one of these, you realize that it's not that I've left it out, it's just something that it is coming. So this will be for grade 6. Who knows, some of your teachers might challenge you this year. All right, so let's say we had an example like this. 1 and 3 over 4 plus 2.5. So we would go about this the normal way. We'd first make the denominators the same. So we'd say 1 stays the same, 3 over 4. I notice I can times both of these by 2, and I get 2 plus 2. 1 times 2 is 2 over 4. And if I follow on from that, I know I do my normal steps. 1 plus 2 is 3. Denominator stays the same. 3 plus 2 is 5. And that is where we reach a problem, is that we've got a mixed number, or sorry, improper fraction as part of our mixed number, which is something that we're not allowed to do in maths. And so next year, you will learn how to take this out of here and add it to there so that we can make this a proper fraction on this side as well. So don't worry about it. I'm just showing you where you might come across a problem if your teachers are going to show you this year. If they do, that's fantastic. If they don't, something to look forward to next year. The second example, doing a subtraction one. Let's say we had 6.5 minus 2 3/4. Go about it the same way. So first of all, make my denominators the same. 6 times 2 times 2, and 2 over 4. Minus 2 and 3 over 4. And then I go 6 minus 2 is 4. Denominator stays the same. And now is where my problem comes. I'm trying to go 2 minus 3, and what on earth happens there? So next year you'll learn how to borrow from your whole number, but not something that you're going to cover right now. Okay, so those are the two that you might come across next year. In the meantime, let's quickly jump back to our presentation. So I did say it does get more complicated next year, but for now, that's what you need to be able to do. Okay, counting in fractions. You really only need to worry about counting in fractions where the denominators are the same, but I am also going to show you the ones where the denominators are different. Just because we've done quite a lot of work with equivalent fractions, and so it shouldn't be too tricky. That's what these two little things are down here. Now that we've got there, I can make them bigger. All right, so this one, what we're going to do is count in halves. So it's 0, a half, or 1/2, 1. And that's because 2 over 2, or 2 halves, is 1. So 0, a half, 1. And then it would be 1.5, 2. 2.5, 3. If you were going backwards, 1, a half, 0. Or if you wanted to start at 5, it would be 5, 4.5. 4, 3.5, 3, 2.5, 2, and so on. I'm just trying to think, if I'm looking at you, which way my pen is going. Am I going backwards or forwards? I'm going backwards for me, but probably forwards for you. Okay, if we were counting in thirds, we'd go 0, 1/3, 2/3, 1. So again, a reminder that 3 over 3 is 3/3, but we talk about the whole number of 1. And if we wanted to go further than that, we would go to, we'd go to 1 1/3, 1 2/3, 1 3/3, nope, 2. Right, the next one. Looking at quarters, 0, a quarter, 2 quarters, 3 quarters, 1. 1 1/4, 1 2 quarters, 1 3 quarters, 2. And I'm sure you'd be able to do that backwards from 1. 1, 3/4, 2/4, 1/4, 0. So I guess the key is to know when you're putting in the whole number. Let's do 6. 0, 1 6, 2 6, 3 6, 4 6, 5 6, 1. 1 and 1 6, 1 and 2 6, and so on. 0 and 8, 2 8s, 3 8s, 4 8s, 5 8s, 6 8s, 7 8s, 1. 1 and 1 8, 1 and 2 8s, 1 and 3 8s, and so on and so forth. All right, I hope that makes sense in terms of counting in fractions. Let's drag this one down here and make him a little bit bigger. He's got some slightly more advanced ones on him. So this time we've gone past 1, and this time also, this is not particularly critical for you to know. You'll be able to see that we put different fractions in the same number line, not on the first one, but on the other ones. So in our first one, 0 1/2, 1, 1 1/2, 2. In the next one, 0 1 8, 2 8s, 3 8s, 4 8s. That's like what we did before. But you could say 0 1 8, 1/4, 3 8s, 2/4, 5 8s, 3/4. All right, which gets a little bit tricky. But you can see how, because of equivalent fractions, it's not wrong because those two are the same. We could also even say 1/2 over here. So we could have said 0 and 8. So let me go with my pen. 0 and 8, 1/4, 3 8s, 1/2, 5 8s, 3/4, 7 8s. My goodness, that's quite tricky. But it's all the same fraction. So this is just looking at how we would count it on a fraction line. I'm not going to go into the next one. I just wanted to show you how you can put the different fractions on the same number line because of their being the same fraction. What you do need to be able to do is to count forwards and backwards on a simple fraction line with the same fractions. And if somebody gave you different fractions, we have shown you how to organize them in either smallest to biggest or biggest to smallest, which is really just forwards and backwards on the number line. And that pretty much covers the normal part of fractions, or these kinds of fractions. There are different kinds of fractions which you'll come to later on this year. But that's it for fractions for now, and we'll move on to a different topic tomorrow. If there's anything you'd like to look at that I have skipped over with fractions, that maybe your teacher's giving you something advanced to look at, please let me know and I'll go through that with you as well. Email me, grade5@worksheetcloud.com, and click on the worksheet above just to make sure that you've understood what it is we did in this lesson. Have a fabulous day, grade 5s. Goodbye.